Okay, in this video, we'll discuss the application of exponential function in the area of economics. And before we do that, we will try to understand the irrational number e as a limit. And we start from this function f of x equal to natural log of x, right? So which means f prime of x. So this is 1 over x. So f prime of 1 equal to 1, right? So what's the meaning of f prime 1 from the definition, right? That means 1 here equal to as h goes to 0, natural log of 1 plus h minus natural log of 1 over h. So that's basically what's the meaning of that. F prime of 1 equal to 1. Use our definition of derivative, right? Derivative is a limit of a rate of change, the difference of y value over the difference of x value, right? So this is basically same as h goes to 0, 1 over h, natural log of 1 plus h, right? Rewrite it a little bit. So this is same as h goes to 0, natural log of 1 plus h to the power 1h, right? And because this natural log function is continuous continuous everywhere, right? The limit, you can move it in and out. So this is same as natural log, the limit of h goes 0, 1 plus h to the power 1h, right? So by our discussion, 1 equal to this. So both sides we raise to e, you get a very nice identity, which is as h goes 0, 1 plus h to the power 1h, this equal to e to the power 1, which is e, right? So this is the very important limit we have, right? As long as h goes to 0, right? And then this limit is a natural number e, right? So that's the second definition for our irrational number e. So this irrational is defined to be this limit equivalent to our definition, right? Okay, so what's next, right? Let's do a substitution, right? We don't like the number goes 0. Sometimes we like the natural number goes to infinity, right? If you let h equal to 1 over n, where n here is a natural number. So which means in this case, if you have h goes to 0, if and only if what? N here goes to infinity, right? So we get another form of this limit. So e here is basically as n goes to n, as n goes to infinity, as n goes to infinity, you get 1 plus 1 over n here, and to the power 1h for sure is n here, right? So this is the first term here is 1. So this is our another very important limit, right? Okay, now let's see the application of this through an example, right? Let's try to make a connection with economics using E here, right? So let's see, let's using an example here. Example here, you deposit $1,000 in a bank, right? So we start from $1,000 and we have an interest rate, right? If you put money in a bank, you will be paid by some interest, right? Interest rate is given by 6%, right? Okay, so there are different way to, or let's say that, right? Let's say 3 years. We want to put in 3 years, right? So denote let A here, A of T here, be the amount after T years. Right? Yearly. So that's a yearly interest rate, which is 6%. And A of T is the amount of the money after T years. We want to calculate, let's try to calculate T here equal to 3, right? So there are ways to compound interest. One way just a yearly compound, right? Then the interest rate is compounded what's that called? Yearly. Then A of 3 is 1,000 for the first year. You get 1 plus 0.06. The second year you time this one more time. Third year you time this one more time. You get that, right? Okay. If the bank is good, they offer compounded like half yearly, right? How do we do that? Compounded like not annually, every 6 months, every 6 months, right? Every 6 months. So a free in this case is 1,000 times. So in the first 6 months, the year rate you get 1 plus 0.03 because that's a half a year. Then you in the first year, in the end of first year, you do that one more time. You do that for 3 years. This is time 6 to the power 6, right? And how about compounded quarterly, right? So this interest is compounded. If this is compounded quarterly, then A of 3 is 1,000 times you every 3 months, right? You do you put in interest, right? In 3 months you get 1 plus 0.06 divided by 4, which is 0.015, and to the power what? Every time you do is 4 times and do that for 3 years. So 4 times 3, right? So this is basically you have different way to compound the interest. And if you do the calculation, this is about 1191.06. This is about 1194.05. This is about 1195.6562, right? And so this is basically if the interest rate is compounded differently, you have a different amount after how many years you put your money in the account, right? Okay, Now let's try to get a general formula for this. Let's assume n here to be the number of compounding period, right? Compounding period, right? Period, right? If you have annually, let us say n is 1, and like every 6 months, n is 2. Every 3 months, quarterly, you get n is 4, right? Or daily n is 365, right? So in this case, by our formula, right, A3 here should equal to 1000 times 1 plus 0.06 divided by n here, then to the power 3 times n, right? Every year you get interest rate n many times, right? Interest compounded n many times. So let's, if interest is compounded continuously, right? Every second, every microsecond is compounded continuously every second, right? So how do we get the amount after 3 years? That means n here is getting larger and larger, go to infinity, right? Then A3 should equal to, as n goes to infinity, 1000 times 1 plus 0.06 divided by n here, 3 times n, right? So that's basically what we have, n goes to infinity, right? So what's this limit, right? So this is equal to 1000 is a number, as n goes to infinity, 1 plus 1 over n over 0.06, right? And to the power n over 0.06, and to the power 3 times 0.06, right? I just put in numbers to match, right? You can see that everything will be canceled except what we have here, right? I just put in 0.06. Why do I do that? As you can see that if you have this and that are same, and that term goes to infinity, that should be e. So that's why we are doing that. So this is equal to 1000 times e to the power 3 times 0.06. So then now you can see that in this formula, 1000 is your starting balance. 0.06 is the yearly interest rate. And 3 is how many years you want to put in your account. So if the interest is compounded continuously, so that's how much money you can get after 3 years, right? So you can substitute in this is our yearly interest rate. This is the number of years. This is the starting balance. So that's one application of the irrational number in economics.